3, 2, 1. Engines full power. And liftoff of Starlink mission.
Look at the size of that.
Check out the scorch marks. They actually reused it.
It's truly something else.
That's the mark. Lock it down at this position.
Roger that. Engaging stabilization clamps now.
Going to space is expensive. You probably don't need me to tell you that, but what I can tell you is that there is a complex process hidden behind that rocket launch. There are three main components that make up an orbital rocket: the booster, the upper stage, and the payload fairings.
Now, in the case of the SpaceX Falcon 9, there are two roads we can travel. The high road is building a new booster from scratch.
A Falcon 9 booster is powered by 9 Merlin 1D engines. These cost about $1 million each.
The Falcon's body is made from a unique metal alloy of aluminum and lithium. And then there's the landing hardware, 4 extendable legs made from carbon fiber, costing between $50,000 and $100,000 each, and paired with 4 aerodynamic grid fins made from cast titanium at a cost of between $200,000 and $300,000 a set.
There's also white paint, which might sound trivial, but when we're talking about a product this big, that's a lot of paint.
Moving on to the second stage. This part of the rocket is expendable, and a new one has to be built for every launch.
Under Fedora, SpaceX keeps production cost at a minimum by using economies of scale. The company built over 140 upper stages.
And then there's the payload fairings, clamshell-shaped panels that make up the nose cone of the rocket and protect the pigeons.
The outer skin is made of high-grade aerospace carbon fiber sheets, which provide rigidity and strength. Those are reinforced by an aluminum.
The fairings are built tough because they're also reusable, just like the booster stage. After the fairings break away,
That brings the total cost of our freshly constructed Falcon 9 to somewhere between $50 and $60 million.
Now, here is where things get interesting. All of this rocket hardware is built by SpaceX in Hawthorne, California.
One of the design considerations with Falcon 9 was that it had to stay small enough to be transported on the road.
The Falcon 9 is transported in segments. The first stage booster is about 140 feet long with its legs folded. The components are wrapped in protective coverings and loaded onto custom trailers to shield them from weather and road debris. From Hawthorne, the Falcon 9 convoy heads east through California, Arizona, New Mexico, Texas.
Oversized load is proceeding eastbound on the I-10, approaching the 40-mile mark. All clear ahead. All units, hold the intersection. The load is halfway through the turn. Copy that. Looking good on the left side. Watch the light standard.
Of course, none of this is cheap. Accounting for the cost of the trucks, fuel, labor, permits, tolls,
The most common landing for a Falcon is going to be out at sea on the platform.
And second, by building his new capital, he'd initiated centuries of city building in what would come to be known as the Empire's Angkorian period.
Now this is still not cheap, but it is much less expensive, and here is what that looks like.
But to build a vast city in the Cambodian wilds, these newly minted Angkorians, as we call those Khmer who dwelt in the capital, would need to tame the natural environment.
See, Cambodia is a monsoon ecosystem with extremely dry and wet periods.
The booster is returned to the launch pad for a static fire test to ensure that everything is working as expected.
In fact, villages along the Great Lake are still built on 30-foot stilts today.
And because SpaceX has so many boosters in their rotation, it's likely to get shelved in Hangar AO for a while.
However, much like the Nile's floods helped enrich its banks with fertile mud, these seasonal floods were key to rice cultivation.
The exact cost of a booster refurbishment is hard to nail down, and to create a sustainable kingdom, Jayavarman's successors would need to harness the power of the monsoon and bend it to their will. And now that we have all of our rocket components prepared for launch, It's time to integrate the 2 stages and the payload into one complete vehicle.
Therefore, they broke ground on an intricate hydraulic system meant to channel the water into the largest hand-cut reservoirs in the world. They engineered canals, dikes, and spillways at precise angles, taking advantage of gravity to divert water.
SpaceX uses a horizontal integration facility located at their launch pad, meaning that the entire rocket is built while on its side,
effectively creating the current environment of the Angkor region.
The first stage is rolled into the HIF and placed on a stand. The technicians then connect electrical and fluid lines.
During the wet season, spillways would evacuate excess water. The second stage is hoisted by a crane and aligned with the booster's interstage. That's a black carbon fiber structure. The management of water, including understanding seepage and evaporation, has been critical throughout history for agricultural development.
The payload is connected to an adapter and enclosed in the rocket fairing. This happens in a clean room to avoid contamination.
But these works were not just practical. They also served a religious purpose.
The encapsulated payload is moved to the integration site, often on a specialized trailer under controlled conditions.
This stunning isometric view highlights the temple's architectural significance. And for some extra context,
the final step inside the facility is to integrate avionics systems like flight computers and sensors, then test them.
And the water itself was sacred.
With all systems checked out, the fully assembled Falcon 9 is loaded horizontally onto a mobile platform, and it's...
During the dry season, craftsmen ventured into the hills to create the striking monument we saw at the opening of this episode. When the streams disappeared, sculptors would gather at the convergence of 2 streams and carve hundreds of linga on the dry bed.
once Falcon 9 arrives at the pad, the mobile platform will use its hydraulic system to lift the rocket to a vertical position. Once it's up, clamps secure the rocket, and umbilical lines are connected to the launch tower for fuel, power, and data.
Given that SpaceX is able to launch at least one Falcon 9 every 3 days, it shows that their integration process is highly...
By factoring in the cost of labor for a crew of between 50 and 100 technicians, engineers, and support staff, we'd be looking at an average cost.
Well, RP1 is a highly refined fossil fuel that's derived from petroleum oil, just like gasoline.
And it's made by the same suppliers that you might see at your local gas station, like Chevron or ExxonMobil.
The cost of RP1 is also pretty similar to gasoline, about $1.50 per liter.
There are only a few refineries that make RP1 though, and the closest to Cape Canaveral would be in Houston, Texas.
RP1 is transported in stainless steel tanks, pulled by semi-trucks, and you need 5 truckloads to fill one rocket.
Meanwhile, liquid oxygen is produced by air separation units, which cool air to -195 Celsius, -319 Fahrenheit.
Given that liquid oxygen has been used in every rocket launch since the 1960s, there are established ASU sites right near Cape Canaveral.
The liquid oxygen is shipped in vacuum-insulated cryogenic tankers, and SpaceX needs about 15 truckloads delivered per launch.
That puts the total cost of delivering fuel for one rocket at about $350,000.
There's another vital liquid involved in launching a rocket: water.
Hundreds of thousands of gallons are pumped into the area directly below the rocket engines in the moments before ignition.
The water deluge works to absorb heat and energy from the rocket exhaust, but it also does an important job of dampening the noise of the engine.
The source of that water comes from the city of Cape Canaveral. City water is drawn from the Floridan Aquifer, a massive underground reservoir.